Okay, I'm going to go through the solutions to this. Right. In an arithmetic series, the 10th term T10 is 6 times the third term T3. The sum of the first 20 terms of the series is 890. Find T1, the first term, and D, the common difference. Okay, so T3, I can't even remember why, but I'm calling it X. And T3, it's arithmetic. So I can use the A plus N minus 1 times D, which becomes, for T3, N is 3, so N minus 1, 3 minus 1. So that's A plus 2D. Then it says that T10 is 6 times T3. So that means it's going to be 6 times this yoke, A plus 2D. Yeah, because that was what T3 was. So that is 6A plus, oh, not 2, sorry. 6A plus 12D. Now, T10 is also, like if I do the same thing that I did over here, then T10 is also A plus N minus 1 times D, A plus, for T10, N is 10, so 10 minus 1 times D, so that is A plus 9D. So this is T10 and that's T10. So I can let them equal each other. So I can go T10 must equal T10, which means I have 6A plus 12, 6A plus 12D equals A plus 9D. And then kind of gather my variables. So if I minus A and if I minus 12D, I get 5A equals minus 3D. And then I suppose you can isolate either, but if I isolate A, I get minus 3D over 5. Now, I have this other bit of information here that I haven't used yet. So S of 20 is N over 2, which is 20 over 2, 2A, and A is minus 3D over 5. What's the rest of that formula? N over 2. Hang on. N over 2, 2A plus N minus 1 times D. I'm going to put that back in here. I don't know if it'll let me, will it? Oh yeah, sorry. Okay, so where was I? 2A I've done, plus N is 20 minus 1, and we don't know D. Okay, so that is 10. If I multiply 2 by minus 3D over 5, I get minus 6D over 5. And this is 19D. That is 10 times, did I bring my calculator? Hang on, calculator run. Okay, I'm back. So minus 6 over 5 plus 19 is 89 over 5, 89 over 5D. Yeah, and it said that the sum of the first 20 terms equals 890. I'm just going to move over a little bit. So 10 times 89 over 5 is 178. What should I just do there? 89 over 5 multiplied by 10. Yeah, 178 D, and that equals 890. And then to isolate D, we divide by 178 on both sides. So D equals 5. So I'm going to put this back in here. D equals 5. And then I have a few equations. There, that one there is probably the best. See here, A equals minus 3D over 5. So A equals minus 3 times 5 over 5. They cancel, so A is minus 3. A is the first term, so T1 is minus 3. There you go. The sum of two consecutive terms, Tn and Tn plus 1 of the series is 289. Find the value of n. Okay, so Tn is A plus n minus 1 times D, which is minus 3 plus n minus 1 times 5, which is minus 3 plus 5n minus 5, which is 5n minus 8. And then Tn plus 1 is A plus, so instead of n, I'm going to put in n plus 1. So it's n plus 1 minus 1, and then D. The plus 1 minus 1 cancel, so it's just n times D. A is minus 3 plus n times 5, so that is 5n minus 3. Now it says the sum of these two is 289. So we add them up. So 5n minus 8 plus 5n minus 3 equals 289. So 10n minus 11 equals 289. Plus 11 plus 11. 10n equals 300. And then isolate the n by dividing by 10. So n is 30. So find the value of n. N is 30. Sorry, I meant to check. I think there's it right though. Yeah, so the first one is right. And it was worth 10 marks. The second one, n equals 30, is right. And that one is worth 5 marks. Okay, and then the next one, oh yeah, this one was nice. This is the writing a recurring decimal as a fraction using infinite geometric series. So hopefully you'd practice this one. 0.1 and then 576 is recurring. So that is 0.1 is not really part of the sequence. So then we do the 576, but keeping the place the same. So 0.0576. And then the next sequence, the 576 would go here. So that is 1, 2, 3, 4. So 0.1234576. And it continues. Yeah? So this is kind of the odd part out. That's not part of the sequence. Series, but the rest is. So this is A. So A is 0.0576. To get OR then, we do T2 divided by T1, which is 0.123456 divided by 0.0576. think it's 1 over 1,000. Yep. So it's 1 over 1,000. Yeah, and then we sum to infinity. So S infinity is A over 1 minus or, which is 0.0576 over 1 minus 1 over 1,000, which is 0.0576 divided by 1 minus 1 over 1,000, and I'm getting 32 over 555. So that is the answer to this bracket up here. Yeah? So we still have the 0.1 out in front. So it's 0.1 plus 32 over 555. So add 0.1 and I get 35 over 222. Yep, that's correct. Oh, it's worth 15. So that's 15 and 5. So is it 30 in total? Yeah. So 30 in total, which is there. Okay, that's question 1. So question 2. A child's swing is drawn back and then released. The first swing is an arc of length 5 meters. Each subsequent swing is shorter than the previous one. The arc length of the first 3 swings are shown below. Assume the pattern continues for all subsequent swings. Okay, so I suppose you can go and check the patterns, but I was pretty certain it was going to be geometric, which means it was a common ratio, not a common difference. So if we do 4 divided by 5, we get 0.8. And then if we check the next one, it's 16 over 5 divided by 4. Sorry, that's stuck there. Yeah. It's also 0.8. So going from term to term, we are multiplying by 0.8. So if we just keep multiplying by 0.8, we get 64 over 25. 256 over 125 and 1024 over 625. Okay, yeah, so that's right, and filling those in is worth 5 marks. Okay, find an expression for Tn, the nth term, and hence an arc length of 15. Okay, so it's geometric, which means Tn is, I always forget this one, there. Okay, so A is the first term, and the first term was 5 times the common difference is 0.8, and n minus 1 we don't know. So, as in, sorry, we don't know for find the nth term. So that is the nth term, I think. Yep. 5 times 0.8 n minus 1. So that's the nth term. And then we do that for the 15th swing. So it's 5 by 0.8 by 15 minus 1. And so do the power first. So 0.8 to the power of 14 multiplied by, oh, what did I do there? 0.8 to the power of 14 multiplied by 5. It says up here 2 decimal places. So I'm getting that T15 is 0.22. And that is also worth 5 marks for both answers. Yeah. So you actually get 4 marks if you get one part right. Yeah. So if you get one part right, you get 4 marks. If you get both parts right, you get 5 marks. Okay, next. On which swing will the total distance travelled exceed 23 for the first time? Okay, so I'm assuming since it says total distance that we're looking at SN. It's still geometric. Sorry. It would be quicker if I knew these. There it is there. Okay. So, SN, no. A is 5. 1 minus 0.8 to the power of n, we don't know, over 1 minus 0.8. And we wanted to exceed 23. So greater than 23? Yeah? So on what value of n will it exceed 23? Okay. I'm going to tidy up a little bit. So 5 times 1 minus 0.8 to the power of n. The bottom line there is 0.2. I'm going to multiply across by 0.2. Again, being conscious of multiplying across when you've got an inequality, but 0.2 is positive, so it's not going to change the inequality. They'll cancel. So 5 times 1 minus 0.8 to the n is greater than 4.6. I'll divide by 5 to get rid of that 5. Uh, 0.92. Okay, so I need to isolate the n. So I'll get rid of this first. So minus 1, that cancels. So I have minus 0.8 to the power of n greater than 0.92 minus 1 is minus 0.08. Now I'm going to multiply across by minus 1 to change those signs. But remember, if I multiply by minus 1, that's going to have an effect on this. So that is 0.8 to the power of n less than 0.08. Okay, so I still want to isolate this here. So what I'm going to do, sorry, that there. So what I'm going to do is I'm going to take log to the base 0.8 of both sides. So log to the base 0.8 of 0.8 to the n, and less than log to the base 0.8 of 0.08. Yeah? So over here I can bring the n to the front. So I get n times the log of 0.8 of 0.8 less than, and I have to talk about this in a second, so I'm just going to write it down. Okay, so the thing on the left here, this yoke, when the base of the log matches the argument, it's just 1. So that whole left-hand side is just n times 1, which is n. Yeah? Now, on the other side, I mean, I mentioned this in class, but so briefly that you may well have forgotten it. When you take the log and the base is a number, no, what's the easiest way to say it? It's a proper fraction. Yeah, as in like it's not a top heavy fraction, it's a proper fraction. So like a half, or like this 4/5 or 7/8 or whatever. So when you take the log and the base is a proper fraction, it's equivalent to multiplying by a negative number. So you have to switch the sign. Okay? So log base 0.8, 0.08 is, so I'm getting that it's greater than 11.3. So n is the 12th swing. That's what I think. Let's give it a go. So if I go back in like here and make n 12, so 5 bracket 1 minus 0.8 to the power of 12, close bracket, over 1 minus 0.8. Yes, I'm getting 23.28 for that, which is bigger than 23. And then if I just go in and try it for 11, yeah, 22.85. So when you do this with 11, so 5 times 1 minus 0.8 to the power of 11 over 1 minus 0.8, you get 22.85. And when you do it for 12, so 5 times 1 minus 0.8 to the power of 12 over 1 minus 0.8, I can't remember now, but I'll go in and change it. You get 23.28. So on which swing will it exceed 23 for the first time? The 12th swing. The 11th swing, it's still less than 23. By the 12th swing, it's greater than 23. Okay. Find the total distance travelled when it comes to rest. That's infinity. So that's just going to be a sum to infinity. So that's a over 1 minus or. A was 5 over 1 minus 0.8. Oh, I didn't do the marks in the previous one. I'll do it now. 25 meters. Sorry, so the 12th swing was right, and it was worth, if I go over here, it was worth 10 marks. 25 is right, and it's worth 5. Okay, so the swing turns through an angle of 114.6 on its second swing. The arc length is 4 meters. Oh, sorry, when the arc length, that makes sense. On which swing will the angle be less than 10, degrees for the first time? So we just kind of need a new sequence, do we? Did I do this one? We need a new sequence, I think. So we don't know the first term, but we know the second term. Okay, hang on. So Tn is, what is it for geometric? I wrote this down. There, a or n minus 1. Sorry. So a or n minus 1. So if I go with the second term, then it'd be a or 2 minus 1. Second term, a or to the 1. Or just a or. Yeah? And we know that T2 is 114.6 degrees. A, we don't know A because A is 5, but 5 is a distance, but we do know the common ratio. So the common ratio is 0.8. Oh yeah, so I can get A. Nice. So divide by 0.8, divide by 0.8, that'll cancel. So you'd assume that if the distances swung along an arc are decreasing by 0.8 each time, then the angle would have to decrease by 0.8 each time because they're directly linked. As in, the angle it swings will trace out the arc. So they're very closely connected. So that is 143.25 degrees. Yeah? So that's the first term. So on which swing? Okay. So we're going to use 143.25 for A, or is 0.8, we don't know what n is because that's the swing, and we want it to be less than 10, so less than 10. Yeah? Okay. I think this is going to go back to logs again. So divide by 143.25, which is positive, so it's not going to affect the inequality. So 0.8 to the power of n minus 1 less than, oh, long decimal, so I'm just going to leave it as a fraction, 40 over 573. Yeah? So I want the n that's up here, so I'm going to do the same thing I did before. I'm going to take the log of 0.8 on the left, and I'm going to take the log of 0.8 on the right. We can lift this and bring it to the front, so I get n minus 1 times the log of 0.8, 0.8. Yeah, and then that's less than the log of 0.8 of 40 over 573. Like happened the last time, because the base and the argument match, that's just 1. And 1 by n minus 1 is n minus 1. Here, again, 0.8 is a proper fraction, which means it's equivalent to a minus. So we need to remember to switch the sign. And then log base 0.8, 40 over 573. I don't know if I'm after typing that right. Sorry, I'm going to type that again. So log 0.8 of 40 over 573. Okay, so that's 11.93. And then we add 1, add 1. So n is greater than 12.93. So the swing greater than 12.93 is the 13th swing. So on the 13th swing, it should go less than 10 degrees. So we can use this and try it. Yeah, it's 9.8. So you again, I don't know, I like to check it, but you don't have to. On the 12th swing, this would be 143.25 multiplied by 0.8 to the power of 12 minus 1. So, to the power. So the swing there is 12.3 degrees. But then on, just moving over a bit, on the 13th swing, so 12.3 is obviously still bigger than 10 degrees. But on the 13th swing, hopefully, if the maths is right, it will go less. So 0.8, 143.25. Yeah, so it goes to 9.84, which is less than 10 degrees. So on the 13th swing, it goes less than 10 degrees. 13th swing is right, and that's worth 10. So I'll just put that down here. So that was 10 for that one. Sorry, zoom out a little bit. Where did it start? Here. So 5, 10, 20, 25. So that's 35. Do I have that marked correctly? Oh no, I have 40. 5, 10, and 10 is 20, 25, 35. Sorry, let me double check the scheme.